All right, so we are going to solve equations that have rational exponents. So they're going to look a little bit funny. Part A, what are the solutions to this equation? We've got this trinomial raised to the 5 has power set equal to 1. So what are the solutions here? So everything inside these parentheses is raised to the 5 halves power, and there's nothing outside of that. So we are going to start by raising this side of our equation to the 2/5 power. You would use your power to a power property and multiply your exponents together and get 10 over 10, which reduces to 1. So essentially it does cancel out that 5 halves power. But we have to raise the other side to a 2/5 power as well. So when we raise the left side to the 2/5 power and it cancels the 5 halves power, we are left with x squared plus 5x plus 5 equals, and then 1 raised to the 2/5 power. 1 raised to any power is 1, and then you can take any root of 1 and get 1, so that's just going to equal a 1. What we want to notice about our equation is we have an x squared equation, so our solving methods will be factoring or the quadratic formula. Both methods need the equation to be set equal to 0, so let's go ahead and get everything on one side. We always try factoring first. It's just faster if we have something factorable. When you have just your x squared leading term, go to your c value. Are there factors of 4 that add up to 5? Your factors of 4 are 1 and 4 and 2 and 2. And so 1 and 4 is the factor pair that we want. So x plus 1, x plus 4 equals 0. And then you use your zero product property. You set each factor equal to 0 and solve, and we end up with a -1 and a -4. So, does x actually equal a -1 and a -4? Well, we don't know. We got to check, right? So, because we got two solutions, we're going to check both of them. First, let's check if x equals a -1. So, we're going to plug a -1 into the left side of the equation. We have a -1 squared plus 5 times -1 plus 5. And that whole thing is being raised to the 5 halves power. We want to know, does that equal a 1? So when you do all this math on the inside, again, grab your calculators, no problem, as long as you promise me you will use those parentheses. Inside the parentheses, that simplifies to just a 1 raised to the 5 halves power. And remember, 1 raised to any power and then taking any root just does give you back a 1. So 1 equals 1. That one worked out. Now we have to check our other solution, which was x equals -4, to see if x does in fact equal a -4. So we're going to say, here we go, we're going to check, does x equal a -4? Same idea, just plug in a -4 for all your x's. So we have -4 squared. Your parentheses are so important on this one. If you are using your calculator and do not put parentheses around the -4, you're going to get a wrong answer. So there's the left side. We're going to raise that to the 5 halves power and see if we get back a 1. So that math inside the parentheses, just like the other one, actually simplified to just a 1 raised to the 5 halves power. And then 1 raised to the 5 halves power is 1. 1 does equal 1. So we actually got two solutions on this one. Both of the solutions worked out when we checked our answers. All right, what is the solution to x plus 18? There's a typo here. This should be say to the 3 halves power. So go ahead and change that. Equals x minus 2 to the 3rd power. I'm actually going to rewrite that. I think I am. Here we go. X plus 18 to the 3 halves power equals x minus 2 to the 3rd power. All right, to solve this equation, we're going to focus on, here's our root. We're taking the square root, so we want to isolate this side, which it is. There's nothing outside of those parentheses. We're going to raise this side to the 2/3 power, which means we're going to raise this side to the 2/3 power as well. Again, the reason why we did the 2/3 is we were just looking for the reciprocal of our power, because this exponent property, power to a power, means you would multiply, you'd get 6 over 6, which equals 1, and essentially we have simplified out that exponent. So on the left side, that simplifies to x plus 18. On the right side, when we multiply our exponents, that's a 3 over 1 times a 2 over 3, which is 6 over 3, which is just 2. So we have x minus 2 to the second power. All right, here's that squaring a binomial. Don't you dare square the x and square the 2 and tell me it's x squared minus 4 or plus 4. You're going to have the wrong answer. So anytime you are squaring a binomial, you have to actually square it off on the side. X times x, x times a negative 2, negative 2 times x, and negative 2 times negative 2. All right, so back to the equation. On the left, we have x plus 18. On the right, we squared that binomial off on the side. X squared, I'm going to combine like terms, minus 4x plus 4. We're solving an equation that is x squared, so get everything on one side so you can factor or use the quadratic formula. I'm going to subtract x with its like term. I'm going to subtract 18 with its like term. So we have 0 equals x squared minus 5x minus 14. Okay, we're going to try factoring first. It's just a trinomial with an x squared. Those are the easier ones. Are there factors of negative 14 that add up to negative 5? And there are. That's going to be a negative 7 and a positive 2. So you set each factor equal to 0, and when you solve, you get x equals 7 and x equals negative 2. But does x actually equal a negative 7 and a negative 2? We do not know unless we plug it back into the original equation and check. So we're going to first, let's check the 7. Does x equal 7? So the original equation says x plus 18, so 7 plus 18 raised to the 3/2 power. Is that equal to x minus 2, so 7 minus 2 cubed? All right, so 7 plus 18 is 25 raised to the 3/2 power. 7 minus 2 is 5 to the 3rd power. So when you have 25 to the 3/2 power, you can quickly do this as we get the hang of these. Do the root first. We're taking the second root of 25. Well, the second root of 25 is the square root of 25, which is 5. And then if you cube it, you get 125. Well, on the right, we had a 5 cubed, which is 125. So we are getting 125 equals 125. So x equals 7 is a solution. So does x also equal a negative 2? So let's check our negative 2 and see what we get. So the original equation, x plus 18, so negative 2 plus 18 raised to the 3/2 power. Does that equal negative 2 minus 2 to the 3rd power? All right, so negative 2 plus 18, we're just going to simplify the left side. That is a 16 raised to the 3/2 power. I'm just going to keep simplifying the left side. 3/2 power, that root is 2, so let's take the second root of 16, which is 4, to the 3rd power, and 4 to the 3rd power is 64. Now on the right side, we have negative 2 minus 2, which is negative 4 to the 3rd power. So if you multiply 3 negative 4s together, you get a negative 64. So I'm just going to carry that down. Does 64 equal a negative 64? It does not. So that means that x does not equal negative 2. The only solution we have is x equals 7.